Welcome to another module of Programming in C. I'm your professor, Professor Fiske, and let's dive right into, well, what are strings? So, going into this lecture, I had to think to myself what I would talk about, because in the last couple of chapters, the last modules, we've used strings prolifically, and we've discussed what they are, but I'm not totally sure that that does it justice. So, what in the hell is a string? Well, a string is really just a collection of characters. And at the C language level, the C or strings in and of themselves are not called strings per se. In most languages, strings are called strings, whether that's capital S or lowercase s. But within the context of C, what you will find is that strings are not represented this way. They are represented as an array of characters specifically. String. If I printed this, it would look just like a string in all the languages. The only difference is the way we build it, right? The way we initialize it on our end and or declare it is dynamically and paradoxically different than other higher level languages other than C. So if I printed this, so printf, and I said, printf, and I said I want to print this string, and I want to use the string format specifier, and then I said @C, what would print? Nothing, because I'm bad. Let's do something for a second. Let me remember. I'm always jumping between languages. Okay. So we're at this. Maybe it's just C. Oops. I don't need the pointer. There it is, stringy. Notice that it didn't say a bunch of gobbledygook and garbage about, oh, you can't print an array, or it's an object array, or this is the memory location. Notice it didn't do that. Notice what the programming language actually did. It produced all the characters of this character array because it understands, well, hold on a second, that's a string. So let's pause for a second and ask ourselves a simple question. How do I declare a string? Well, that's not that difficult, actually. What I did here is the easiest, most efficient way to do it. I didn't give it an amount of space, and I didn't do anything special. All I said was, this is what I want you to initialize this character array with, and it did that. Now, what did this actually do? Well, it created what's called an immutable data type, or data structure. And what that immutable data structure, why is that data structure immutable? Well, it's immutable because you can't change the size of an array, the amount of spaces, or the amount of memory locations an array contains after the array is initialized. I will say that again. You cannot, under no uncertain terms, change the size of an array after the array is initialized. That is very important. Because once this array is real, meaning it has data and whatnot, the size of the array is not changeable. So you might be saying, well, Professor Fiske, how do they change then? You know, the Mickey Mouse voice has been public record now for a long time, for the last year or so. Either way, the way that changes is you have to create a new array with a larger size. Take all the values that sit in your old array and put them in the new array in the correct positions you would like them to be. So if I wanted to create an array and I knew how many spaces I wanted, I can type that into the indexer. And I can run this. Now, what's going to happen? Well, I'm still going to be fine because the amount of characters required for my string are not more than the size of the positions in the array. But what happens when they are? What happens when they are? Well, notice my interactive development environment is already saying, yeah, you can't do this because the size of the array is not large enough to contain stringy. But what is C going to do? Is C just going to error out, or is it just going to print S? It just printed S. Now, one of the problems with this is that if this occurs, you're not running into a runtime error because it didn't fail at runtime. You got no errors. It didn't fail at compile because it also you didn't see any errors throw. No. This is what's called the logic error. And logic errors are far worse than runtime or compile errors because logic errors are not errors that are a rule-breaking error at the CPU level. The CPU is saying this is totally and utterly allowed. I just don't have enough spaces to save the rest of that, so I'm just going to save the S and move on. And then when you ask for that array back, when you said, hey, give me the C array, I want the stringy values, right? stringy. Guess what? It says, but you only saved S, so you're only going to get S. Now, you could wire up your interactive development environment to throw an error, to say if anybody ever tried this, throw an error. But in this case, I haven't done that. So in my interactive development environment, it's not going to throw an error. It'll throw a warning, which most people tend to ignore. Now, one of the things I would say is when you create a string array, it is very important that you initialize the array with the string, because I cannot, and for all intents and purposes, let's do some stuff. I always talk about not doing this, but there are situations where you just initialize the array because you really don't know, you don't have the value yet, you're going to get it in a minute, or the array won't be in the right scope. Let's say you have a for loop, the array can't be initialized and the for loop does do something to it. No, that wouldn't make any sense. Or, yeah, it can't be initialized with values. It can only be initialized with values after the loop is running. Then you'll declare it like this. But what if you just said, okay, now I know what the value is. Can I do this? Can I do this? Well, it's already mad about that, because when you do a char array like this, or a string array, or well, it's a char array really, you can't do this. You can't. Because what this is doing is it's saving this entire value, all of the pieces of this, string and y, in the same location, or in the entirety of the array. That's not possible in C. What you actually need to do is we would need to use a function that would save each specific letter individually in each specific variable or value location in the character array, in the 0th, 1st, 2nd, 3rd, 4th, 5th, and 6th positions. Now, if I wanted to do that, I can do that here, and I can say, you know what? I want you to store the S character, and the T character, and the R character, and the I character, and the N character, right? And the G character, and the Y character, and then don't go any further. Stop yourself. Right, so we'll say 0 like that, or I'm sorry, it's it looks like this. And that's not the right one. Yeah, it looks like that. And now, let me erase this. If I said print this guy, it would print it as stringy, right? Boom, we're good. But let's look at it in a debug session if we can. I was about to eat my words about debugging and REPL. I absolutely love REPL, but sometimes it leaves some to be desired. I hope they continue to flesh this out, because I think it's very powerful, especially for students or individuals like myself who just want to develop on the fly, and I don't want to have an environment set up to do so. All right, here we go. So we're going to start the debugger. I put the breakpoint at line 6 because I want to look at the char array, C. Okay, great. Let's scroll down and see what we see. Notice that on the left-hand side, that the position of the letter S is 0. Remember, we went over this in our arrays module or micro lectures, that each letter represents a position in the array, and each position is a key. So the S and the 0 are tightly coupled as a data pair, with the 0 being the key, and the S, the character S, lowercase s, being the value. We call these key value pairs, okay? We call these key value pairs. Now, these key value pairs are not very valuable to us because the number 0 means nothing. It literally means nothing to us as developers, as humans. It means something to the computer because the computer understands where in the memory allocation in my random access, remember pointers, it knows where that is. So it says, well, I know where the 0 is. It's at 0x00FAA1BDE, blah, 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 right? But those memory locations aren't relevant to us, so the number 0 is irrelevant to us. We just need to know that if I looped through this, I would get 0 as the key of this specific function, or this specific array. Great. But what happens when I print it out? What will it look like? Well, let's go to the top and notice, okay, I apologize. Notice how big this array is. This array is 50 characters long. Why is this array 50 characters? Well, yes, because we told it to be 50. That is the immutable length of the array, and that is what cannot change. The values in the memory locations can change, but the actual array size, the actual amount of positions in the array cannot change. If I continued forward, what happens? I get the same output because C understands I am printing characters as an array, and so therefore this becomes a lot easier. Now, I know I'm doing this after the fact if you're taking my course, but how do you save a value from the user to your array? Well, what you can do is you can just declare the array. Remember what I said about declaring arrays? Sometimes you have to. It is not always advisable, but sometimes you have to. So we'll declare the array with the size of 50. And then we'll say printf, please enter your name. All right. How do I get a value from the end user? Well, I would say scanf. And I would say, oh, my apologies, that is not correct. I would say data or format specifier S, and then I want the computer to provision. Oh, I'm sorry. No, this is, yeah, we'll change this to name. Great. And now what I will say is name, your name is, now let's run this. It's going to stop, and it's going to ask me for my name at line 6. Please enter your name. I spelled that wrong. Stop, run. So at line 6, it's going to prompt me at line 5, please enter your name, and it's going to stop at line 6 and wait for me to respond. My name is DevDoctor. Let's step. Oh, enter. Right. Your name is Dev. Now, why did it do that? Why did it not store the whole thing? Does anybody know? The reason why is because I put a space in between my first name and last name. And it created an issue where it did not really take into consideration if there's anything after that empty string or space, if you will. So if I wanted this to work right, what I actually need to do is I need to point. I believe I can point. Let me see for a second. I can use a pointer to fix this, if I'm not mistaken. I might be completely wrong in being able to fix this, and it's already telling me that this is not necessary. I think you can't get around the spaces. I will actually do some research on that, but I don't think you can get around the spaces problem. So if you have a string of spaces, you would probably need to care for that in a way that doesn't make your life a living hell. Another function that we can use is fgets, but I don't necessarily think I want to go any further. What I actually want to do is I want to stop here and say, I've really enjoyed doing these lectures with you guys. It's something that I do in my spare time. You know, I don't make a lot of money doing it, but I do like the fact that it's giving me some, you know, the ability to talk to you guys. So if you like this content, please like and subscribe. Otherwise, I would say, like I say in all my videos, good luck, have fun, ciao.